Today we continue what we did yesterday, but focus more on the remainder and factor theorems, which you noticed yesterday. Let's do that f of x be equal to 2x to the fourth minus 15x squared minus 10x plus 5. Let's find f of 2. Again, we could just plug it in. But instead we're going to use synthetic division real quick. We put a 2 down for the first coefficient. Notice I skipped x cubed, therefore there needs to be a 0 there. Minus 15, negative 10, and then 5. We plop our 2 down there. 2 times 2 is 4. Add them, you get 4. Then we get 8, negative 7. And notice how quickly you can start doing this. You get negative 43. The remainder theorem says that f of 2 is equal to the remainder at x equals 2. So it's right there. This is the remainder. That is equal to the function value. So basically, we could plug this in like we did, like you did back in middle school, or we could use synthetic division, find the remainder, and this here will be the answer of plugging back in. So it's really all it says. The remainder theorem says that the function value is equal to the remainder at x equals 2. What's good about that is that leads us to the factor theorem. Well, the factor theorem, and this is the pivotal part of this chapter, is if the remainder is equal to 0, then that x value must be a factor of p of x, where p of x is a polynomial function. And I'll give you more official things in class. But in the end, what this really says, if you get a remainder of 0, then that's a factor. The whole goal of this chapter is to take this f of x up here, and we want to factor this. Now sometimes differences, squares, grouping, all those different methods do not work, but synthetic division will be able to factor it for us by the end of this chapter. So let's take another example. Well, g of x is equal to 2x cubed plus 5x squared minus 23x plus 10. And if we want to plug in 2, we want to see if 2 is a factor. We put 2 on the outside. 2, 5, negative 23, and 10. Bring down your 2. 2 times 2 is 4. We get 9. 2 times 9 is 18. We get negative 5. And 5 times 2 is negative 10. The question really is, what does that mean? So let's go back to something from your early elementary years called long division. The only difference between this long division and the long division you did back in elementary school is we're going to do it with variables. Because the idea is, you understand this is a factor, but this means something too, and we've got to notice this. So here's what we're going to do. We're going to take 2x cubed plus 5x squared minus 23x plus 10, and we're going to divide that by x minus 2. And your question probably is, why is x minus 2? Because if you were to factor this, for that to be an answer, it would have to look like this, equal to 0. That's the only way that this would give you a factor of 2. So we're going to divide it by the factor expression, the linear expression of that factor. So now, on the outside, we put x minus 2. Remember, we're doing long division, not synthetic here. On the inside, we just put the entire polynomial function. It's actually a very easy task to do. You only look at the first x and the first one that you're looking to go into. and you say x times what gives you 2x cubed, and that would be 2x squared. So I'm going to put that above here to hold my place. Again, I'm lining things up. This is the quadratic column. I'm going to simply multiply this back down. 2 times 1 is 2. X squared times x is x cubed. If you did it right, this first column should cancel. 2 times negative 2 is negative 4 times x squared. And now we just subtract. This minus this cancels. This 5 minus negative 4, 9x squared. And bring down the rest. And we do the same thing over again. X times what gives us 9x squared? (9x). 9 times x is 9. X times x is x squared. Again, notice they're going to cancel. 9 times negative 2 is negative 18. X. And again, we're going to subtract. Those cancel. Negative 23 minus negative 18 gives us negative 5x. Bring down plus 10. One more time. X goes to negative 5x minus 5 times. Negative 5 times x is negative 5x plus 10. When you subtract, you get 0. This here is your remainder. That's what's left over. And this here is your polynomial. What this tells you is if this is a factor, this tells you that x minus 2 times 2x squared plus 9x minus 5 is equal to the original expression of 2x cubed. You just factored one factor out, and now we could actually factor this if we really wanted to try. I'll leave that as something you guys can do on your own. But what we're doing here is starting to build a process. If we can find one factor of a cubic, we might be able to factor the rest of it and solve for all the zeros. Let's do one more long division just because I know it's something which you're not as comfortable at. So let's do the first one. Let's divide 2x to the fourth minus 15x squared minus 10x plus 5, and it's divided by x minus 2. First and foremost, the first question should come up is, why are we doing this if we can just use synthetic division and find the answer like we did in the first one? Going back to it, this answer was right here. It's 2x squared plus 9x minus 5. So why do long division? Synthetic division only works if you're dividing by a linear factor. And during this year, you may not always be dividing by a linear factor. So we have to make sure you guys are okay with long division, even though synthetic division does get you by on probably 85% of the work. So let's do long division. X minus 2 divide into 2x to the fourth minus 15x squared minus 10x plus 5. Let's do it again. X times 1 gives you 2x to the fourth. That would be 2x cubed. I didn't leave a space there for my x cubed term, so I'm going to have to sort of cram this in here. 2x to the fourth minus 2x cubed. Sorry, minus 4x cubed. Subtract. This cancels. I'm left with 4x cubed minus 15x squared minus 10x plus 5. Next step, x goes into 4x cubed, 4x squared times, and we're left with 4x cubed minus 8x squared, and subtract. Cancels like it should. Negative 7x squared minus 10x plus 5. X times what gives you negative 7x squared minus 7x. Negative 7x times x, negative 7x squared plus 14x, and subtract again. Those cancel. Negative 24x plus 5 one final time x goes negative 24x minus 24. So we have minus 24x plus 48, subtract negative 43. So the answer is 2x cubed plus 4x squared minus 7x minus 24 minus 43 over x minus 2. That is the remainder. Just realize you have to write it as a fraction here. For example, if you did 5 divided by 2, you get 2 and a 5 twice, and then you get a remainder of 1, so it's really 2 and 1/2. That's what this term represents over here. This represents the remainder term, and this is the polynomial term. Look at the front again. Just remember these numbers, 2, 4, negative 7, negative 24. And you can see again, 2x cubed plus 4x squared minus 7x minus 24, and then plus the remainder term, which is the answer when you plug it in. It's important to notice that every time you use synthetic division, this drops by a power of 1 exponent, and that's how the answer is visible. So the remainder and factor theorems are going to be the basis of the remaining part of this chapter. So that should conclude these two theorems. I'll see you tomorrow.